greetings, Webby folk. So today we are looking at creating an interactive experience over the web with Golang. How did you all do with the challenge I set? That was to make some interactivity on the server and actually store the changes in the game. I found it surprisingly tricky, so well done if you managed it. I actually planned on this lesson being a pretty quick response to that challenge, completing it and moving on to cookies and working on multi-user. However, the challenge was much harder than I expected. So instead, I mostly ended up building the background structure to the game, which is useful stuff to have. So hopefully you'll enjoy watching me build the background structure so that the game works online at the front end. When I got to the bit about finishing the template, I found that there were too many changes I needed to make to actually how the templates were thrown together, and that was going to be too complicated, and it felt like it was worth making into another lesson. So today's lessons are going to be maintaining larger projects. I also did a whole ton of restructuring, so you can see me restructuring this one and see whether you like how I've done the restructuring. Also, maintaining a single game object for players to be able to access and change with each interaction on their browser. Next week, we're going to be looking at templates in more detail and all the things you can do with them. They are really powerful and totally worth getting into. And the week after that, we're going to do cookies and how to handle multiple users. Here's how I got on with everything on the challenge, though. Let's get on with it. So here's our game struct. We've got the player struct, so we know their deck, their current score if they're human. We want to also be able to pull up other information here. So last one may actually be less relevant than I expected, because now we're going to have instead rounds, which will be it's going to be a slice of type game round. Type game round doesn't yet exist, and I'm going to make them pointers because that feels slightly easier. So let's have a type game round. Type game round, and that's a struct. And the core of this is, of course, going to be the played, which is the cards. So that's going to be a slice of ints. Possibly we're going to need to keep track of its turn. We need at least a first, I think. So whose turn it's going to be first. And that's also just going to be a straightforward int, because that's going to be a player. And then we should at least be able to just check through, see who's played in round. I was going to put a method in the game round to do it, but I'm going to make a new game round thing. So we've got a new game function. But now the game doesn't store a last one. Instead, it stores rounds, which is pointer to game round, and it's empty. Right, so we're just going to send it a list of all the rounds that have happened so far. So that's an empty. I just try and explain what I've done here. This is saying it's a type. This is a slice of game rounds, just like this is, and this is initializing it with nothing inside. So it's an empty array or slice of game rounds, because nothing's going to happen in there. We probably could do with a new game round. So let's have one of those. Func new round. Or we'll write game round. Slightly clearer when I come back to try and read it, what I'm talking about. And this will obviously take the number of players, m players, and it will take first. That makes sense. And both of those are ints. And in this function, the first thing we do is we return a pointer to a and is so and game round, and the contents of this will be a make of the number of players, make int and n players. Oh, that shouldn't have a comma there, n players. And the second thing that this takes is first, straight up just takes it in. And then we have made our game round. And there is a problem, because I forgot. That was why I needed a comma. Comma, and then close bracket here. When you get a big problem like that, it's probably because you've forgotten to close a bracket. And then it just doesn't know what to do with so much other stuff. There is something that's been bothering me a little bit about this project, and it's starting to get too much stuff in one file, and I'm finding it hard to keep track of. I'm going to break it apart now, find the functions I think can go in different places. There's definitely a feeling of the console game has its own functions that ought to be in the console game section. There's a feeling that the web game needs to have its own section. And these structs, definition of a game, definition of a player, I feel like they want to go in a place where I can see structs and see that kind of stuff. So let's do some reorganization. So I'll quit this, and this was our introduction, so I'll get rid of that. And let's make some new folders. Make directory types. So we got a directory called types, and in types we're also going to make a directory, because obviously every part of the project will be a directory. That seems to be the best way to organize it, so you can keep track of where everything is. Pure is where I'm going to put all the pure functions for, and the last one is going to be a console. mkdir console. Vim back into candlestick.go. There will be a few problems as I try and get this working. Tab edit types stroke types.go. Obviously package type. Do I put that in string? No, you don't. Package types. I don't know what we're going to need to import right now, but I'm definitely going to pull these. Basically, I'm going to take the struct and their constructors. New game, new player. Pull them out and put them in here. No, I'm going to put that in types. It feels like it really belongs with the type player. This is a console one. Yeah, it's using ASCII card, so I'm going to control tab edit. And I called that console, didn't I? Console. And I'm going to write that as console.go. And this is package console. And then we'll come. Oh. Yeah, these are definitely console things. So we can get rid of them, and I don't have to see them cluttering up my thinking. Put them in here. So yes, a brief lesson in package management, I suppose. Honestly, package management is something I am really learning at the moment, and I'm trying to get my head around. I do find it helpful to have these packages sorted. So, function contains returns the number of elements in a slice that match the comparator. To be fair, that's just a pure function, isn't it? It doesn't need to know anything. I'm going to stick it in pure. Oh, undo that. It's not quite ready. I haven't got the tab edit. Pure dot go. Of course, because this isn't just package pure.go, this is package candlestick.pure.go, so it's, well, stroke pure.go, so it's not gonna upset anything else if they feel like having a pure set. Beats. These are the ones that I really felt like needed to go in pure, because both the web game and the console game will use. Put those down here. Make deck. That's going to go in types. Round. This is a console one, I think. So get rid of that. Okay, so we got round, play game. This is the console version of the game. So we can get rid of that. Put that in console 2. There's going to be a ton of complaints about missing dependencies or used and not copied. And these will obviously now need to, or game will now need to be a type. So we will import candlestick stroke pure. And we're going to import candlestick stroke types. Game. It's a pointer to types.game. Here's our handler request. Here's where we wanted to play around with the game. So we've started the game. First thing it's going to need to do is look at the state of the game. The option here is we need to start actually playing the game. Currently, it has just been created. The rounds are all empty. So we go through the current round. So CR equals game dot rounds. Oh, if round I think our new game function doesn't set it to completely empty. The first thing it does is it creates a round. Just put in one. It's a pointer to game. It's a slice of so I can just put in new game round, and this takes two parameters: the number of players and players, and first, which we'll set to 0 on this time. That's so CR equals game round, game.round, and we want the last element of this array, so it's len. Is it round or rounds? It was rounds, wasn't it? Yeah. rounds len game dot rounds -1. Now that CR is set to that, we can move to the next part of the project. No, we need to loop through that round. I feel like the round needs to be able to be asked a question. Like there are two possible responses. We say take turn. Whoever's turn it is needs to take their turn, and if that player happens to be human, but of course the round doesn't know whose turn it is, so we can't make that a direct function on round. I'm going to make it a function on game that works out whose turn it is as it looks at the rounds. Yeah, I do think that this can be a function somewhere. More tricky than I expected, but I didn't expect this to be the easiest project. We're looking at a game rounds, length of game rounds is -1, so we found our round. Why doesn't the round keep track of another number? Yeah, we'll have the round keep track of another number, which is which turns have been taken. Then we can ask it that in the class. So here with the game, we're going to have a function func, and this will take a type. We'll take a pointer to a game. Take turn. We'll call it try turn. If it's a bot, then it can play. Because bots are just playing the top card, which is terrible. At some point, maybe. No, I'm not going to be writing bots for this game. But its return result will either be the turn taken or whose turn it is. Will either be. How do we distinguish these results? Because if it's a human's turn, then we have to stop and ask them to make a choice. If it's a bot's turn, so other detail, game round, current, and that's an int. When we make a game round, current is also set to first, right? But that will change. So there's a couple of things we need to respond with from try turn. My inclination here is to make a couple of constants. We'll return two ints. The first is the message, and the second is the player whose turn it is. If not, and I'm going to create some constants at the top. Const bot moved equals 0. Const human turn equals 1. Const done 2. Yeah, I don't quite like those words. It's turn bot turn human turn done. So that's still not completely turn round done. If it returns human, that means you need to do a thing. try turn. So the first thing it does is it will get the turn from the round. So CR equals, as before, CR equals, I'll call this G. G dot rounds. Oh dear, did I make that lowercase? Bad. I can probably get away with it in here actually. But I'm going to make that uppercase now. G dot rounds. That's because, in case I haven't talked about this already, I have, but uppercase means it's publicly accessible outside, and now that I've shifted everything into smaller packages, a bit of access might make a bit of difference. Rounds equals G dot rounds at len G dot rounds -1. So our current round is there. And then we can ask some questions. One is, whose turn is it? So turn equals CR, oh that should be a colon equals, CR dot current. We don't even need that. CR dot current is nice and easy. So if CR.current players CR.current and it's G.players CR.current equals dot is human, and stick a big knot at the front of this because we're looking for we'll do if they're human, then we return first turn human, comma, and then CR.current, and it's their turn. So the game responds by saying it's this player's turn, ask away. And since that returns, we don't need an else. So the next question, we now know that they are either a bot or the assumption here is that the current player is now a bot. So now we get G dot, again, capital P, G dot players. If we know they're a bot, CR.current dot. How do we do choose the bot take a card? This is func. I'll call it P. See, this is all, I've written self here, and that's all very nice and Pythonesque. And I was just watching a video today, about 2 days ago, and he said, you know what, if you're writing Pythonesque code in Go, something's wrong. So, and I can kind of see his point. I feel like self is really clear. I didn't do any underscores, at least. Is P been used in there? So let's replace that with a P. And no, that doesn't. We'll do it here as well. Oops, something's wrong. P.deck. Oh, here it is. P star player play card, and this will play the card N. And play card by position is just you take res colon equals p dot hand at n. P dot hand equals append. Oh, this is the fun bit. P dot hand. I'm slicing here. I'm just struggling to work out which way round it goes. It's everything up to n and comma p dot hand everything after n, but I'm trying to remember which one's inclusive and which one's not. It's not complaining as much. Missing comma somewhere in an argument list. So that compiles. I need to write a test for types.go to make sure I'm getting the right responses here on a hand. So I need to make a player and then play a card at a position, and this will return an int, won't it? And then return res. Tab edit type stroke test type dot go package types import at the very least testing and func test, capital T, test play and that takes, it's a T of type test, which is a pointer to testing.t. P colon equals new player. What does a player need? Is human. Doesn't matter. New player. We'll say true for now. Now at this point the cards are going to be random. The thing we can access though will be the size of his hand. And there should not be any duplicates in his hand. So h colon equals p dot hand. When the other one gets sliced and put into, this one won't change, hopefully. We can play the first card in the hand each time. P. For I. P dot, and what was the function we're calling? Play card pos. Play card pos. Naught, comma. Oh, play card pos not. I. C colon equals. Oh, I got an idea. For I colon equals naught, semicolon I is less than 3, semicolon I plus plus. The okay, so we can ask some questions now. If h dot, oh, should we put a draw card in the back of that? I think playing a card actually does allow for a draw card to happen. So p dot draw cards 1. Okay. If h at 0 does not equal c, we have a fail. Yeah. Fail. T dot fail. I think it's t dot log as well. T dot log. Computer log f. I equals %d, c equals %f, %d, and h I equals %d, new line. And here we're going to put those three things: I, comma, I, comma, C, comma, H at I. If len p dot hand is less than 3, does not equal. This is probably the more important test for me right now. Does not equal 3. So if the length of the hand is not 3 after having done this, then either I've not taken a card or I've taken too many cards. T dot log f hand len equals %d len p dot hand. So come over here, cd script, go source candlestick, cd types, go test dash v, good, we've got lots of problems. Isn't programming fun? Types 21, too many arguments to return. So that's probably because I forgot to put the return type on that 21. I did indeed, I forgot to put the answer, the return type, which is of course a pointer to game round. Types 36, so that might actually fix quite a few problems, so it's probably worth compiling it, trying again. Types.go 41 g dot. Aha, capital I, because let's get rid of lots of them. 46 evaluated but not used. Oh yeah, remember when I left that thing and just ignored it, so I stuck a to do with it? Here it is line 46. I'm just going to block that. This is missing a return then. Return 0, 0. Uh, 65 cannot use p hand as type That's the second half. I need to put the dot dot dot. So the dot 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 here turns an array into a string of its contents, because the way if you receive a long set of arguments, an unknown number of inputs, you can't just comma them out. You have, well, these should be comma separated, and that's what the dot 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 does. It says comma separate these to the input. So that should at least fix that problem. Undefined self in self.dec. 72. 72. Oh yeah, that was what I was saying. I was switching from this to switching from using self, because self is Python and I'm writing Go. Self is a really nice name for this. It says the object we're working on in whatever case, but this is Go. 88. Undefined rand in rand.int n. Oh yes, of course, we need to import rand. Keep saying dot. I'm used to thinking in dots, but Python, it just looks a lot like a file path, doesn't it? That's because somewhere along the line it is. I don't know exactly where it is kept. But no test files? I wrote a test file. Oh, is it the wrong way around? Yeah, it's the wrong way around. It's got to be underscore test.go. Okay, so we'll quit this. No. Right, ls move. I prefer to have the test first, actually, to types test.go. Okay, and now when we run the test, pass the test. Hang on, no, that's not a pass. It's supposed to fail at that point. Did I forget to put the word fail? Okay, how edit? Types test.go. Oop, undo. T.fail. There we go. And now it fails because the hand length keeps getting longer. And that should be HI. But it looks more like it's not taking them out. Onwards and outwards. Let's see if we can get it so that test does pass by changing one of these things. P dot hand equals append. There's the slow way of doing this. I just kind of liked new hand equals and it's an array of ints, right? Colon equals make int. I'll just put a 0. For I equals 0, I is less than length p dot hand I plus plus. Oops, semicolon missing. And in here we just put if I does not equal n, then n hand equals n hand dot now equals append n hand with p dot hand at I. This is the way that makes a lot more sense. Slice notation, if you can get it right, it's really quick. Sometimes it's a bit tricky because it's hard to remember, and you've got to cancel the edge cases. Something's missing brackets wise here. Let's have a peek down here, find out the first place. Line 70. For I equals, I colon equals 0. I is less than that. That will make more sense. And now it passes. So I wanted to try and use slices because they're nice, but sometimes just running through a list is easier. So what I've done is I just created a new list, kept appending to it with the ones that weren't, as long as they weren't in the position. All that so that here I can just do cr dot played at cr dot current equals g dot players cr dot current dot play card pos 0. And then cr dot current equals cr current plus 1, and then we mod that I don't know if I'll cover modulus. It basically just counts around. So if you're working mod 5 and then it goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. If you want to take a number that's much higher, like 8 modulus 5 is 3, because you take away the 5 and you're down to 3. If you're going with 13 modulus 5, you take away 5, you still got 8, and you take away 5 again, you got 3. So it's just the remainder, basically. Modulus n. We know how many players there are. It should be, well, length of g dot players. And then the question is, if cr dot current equals cr dot first, then this round is finished, and we can return turn done. Comma 0, and in this case we'll replace that with turn bot. So that says the bot took their turn, so try again. Now here's a fun part. Here's where we can keep track, or here's where we can make actually the changes, because this is the point where we realize who has played what. So this is the point where everyone has played their card. So now we can send this to, we need to import it, pure. So import candlestick, and pure doesn't, I think it doesn't care too much about types. Func contains beats, because this is the method I need right now. It's decide trick. Yeah, and that just takes an array of integers. The played cards, right? cr.played. So when win P, comma win C, colon equals pure dot decide trick, and that's CR dot played. Where do I put those? I'll just put them in the struct, the winning player. There you go, call it winner. So that's in game round. Oh, yeah, no colon. So now that we've got our winner, we can actually create the next round knowing who's going to start it, can't we? So, G dot rounds equals append G dot rounds, and we append that with a new round, which I think was called new game round. And a game round took the number of players, which we ought to know by now, but it's ling. And the other property is whose turn it is first, which happens to be CR.winner. I have miscounted brackets. What if I put a bracket here? Well, no, it's not complaining. That's something. Try and put it a bit wider so I can see this more clearly. So append the rounds with the new game round. Bracket there. Brilliant. No, I think we'll do a separate function for human turn. So we've received something that says this will return and say it's a human turn. So we get something back. We'll make another function for human turn. Func. And this will also be a game thing. G star game. And this is human turn. It takes an int. C. Should be able to work on the assumption that this does leave us with a human turn. Here's the card is chosen. Many things that happen here are similar, but they're not quite the same, are they? CR dot played. Oh, we haven't got CR yet. We need a CR. CR colon equals G dot rounds len G dot rounds -1. CR dot played at CR dot current equals G dot players dot play card pos, and this is a whatever C is. I mean, how many lines of code is that? 1, 2, 3, 4, 5, 6, 7. 2 functions need it. Now I'm just going to copy it. I actually think it's probably tidier because I still need to do something with the result if I do it in here. So that's going to be a couple of extra lines of code. Ton to make the function. So do that. We yank that and put it here. Return turn round done. Or This doesn't need to have a return type, does it? So we'll just play a human turn based on the card that's given, and it will be a position. We will make sure before we call human turn that we know that the card is safe. So that's probably something to clarify. Oh, and that's probably why we need to return a bool, say whether it worked. We'll put the safety in here. Bool here is okay. So what we're going to put here, this is human turn takes a card and moves the game on by playing that card. The thing I haven't yet decided, params C card name. So that's actually not something I've done. I've actually taken the code so far doesn't take the card name, it takes the card choice. But now we return a bool. At this point here, we can actually return true. Now we do a quick check to see if that card is in his hand. So, and flip that to a pos. So we need that. So here, this is check cards in deck, and this for I in g dot players cr dot current dot hand. And it's not in, that's Python code. It's I colon it's K underscore comma V colon equals range dot hand. So V will be a card. We need a result. Pos colon equals -1. If V equals C, pos equals, oh, okay. And now we're going to play card pos. Okay. So it turns out the challenge I set you was pretty big. But you didn't have to do quite everything that I've been doing. I haven't even managed to get the important thing that I wanted to done. And I've been going for an hour and a half. No, I feel so close. So, DD that. So the first thing it does is it sends you a blank game. Yep. If error is not nil, then we have an A. So the expectation is we're going to be trying to do human turn. If human, oh, it's game, isn't it? Do we have a game? Yeah. Game dot human turn A then we have stuff we can do. Otherwise we'll just print it as it was. Then for A comma B colon equals game dot try turn if a equals types dot turn human return. This actually doesn't have a done case, so this could cause some wobblies. Let's oh, and also it's not return, it's really just break. Okay. So let's see what we get at the there's plenty of things that can go wrong here. Go run candlestick.go. Many problems. Good. Types.go 27. Two true values in struct initializer. $60. Played is fixed many of them. We've got an undefined K because I put the K and never actually made it. Okay, that's types.go 60. 60. I totally define. Oh. Pause, and of course I need to check here if pos equals -1, return false, which means it wasn't okay. So that's just something I missed. 66 cr.first undefined, but it does have a first, so let's find some firsts. That doesn't actually matter. Or that, or that. Imported and not used. Oh right, we get to the next stage. Imported and not used. Candlestick pure. And imported and not used mylib.ask. So which functions are not using them? Candlestick.go. Oh, hang on. We're using types. Apparently I don't need that, and I don't need whatever's on 7 now. Yep. And on line 60, or now probably 58 it should be, we have a new game, but it's not just new game, it's types.new game. Be declared and not used. Line 28. Which program? Which function? 28. Ah, that might come in handy when we try and make it multiple players, but right now we don't need that. Server started. Sweet. So Control R this. Please choose a card, but there are no cards to choose from. So now the problem is with our template, I think. So let's have a quick read of the template. Tab edit templates dot. It looks like I deleted some of this. Well, let's try and put some of this back. I don't think I intended to delete something happened here. So range $a, not a player. I'm pretty sure it's a struct I can access dot hand and end that, and we'll make it a link. Ahref equals dot comma close the A, stick on a new line. Okay, Control C, start the server. So I'm not quite sure why that got kicked out. So now we have our cards we can choose, but that's all we've got. We now have a different set of cards, 10, 8 and 7, is that right? So if I click on 10, do I get, yeah, 10 changes. If I change the 8, the 7 and 13 should go up. So this looks like stuff is happening in the background where the card I'm choosing is actually being pulled in the game, but I'm not getting any extra information about that stuff. But this is all available in the game structure, see? So